All right, let's jump into some fascinating AI research today. We are looking at how to improve large language models, those AI systems that can write poems and code. We want to make them even better at thinking.
Thinking better, huh?
Yeah. And the paper we're diving into is called Deliberation in Latent Space via Differentiable Cache Augmentation.
Okay, wow, that is a long title from the folks over at Google DeepMind, I see.
Yep, DeepMind.
It sounds pretty complex.
It is, but also super interesting. So you know how sometimes LLMs seem to struggle with complex reasoning? Like they can give you facts but not really connect the dots?
Yeah, I've noticed that.
Well, this research tackles that head on.
Interesting. So are they, trying to rewrite the core code of the LLMs?
That's what I thought too, but no.
Yeah.
It's more like giving the LLM a tool, a coprocessor.
A coprocessor, like an extra brain.
Exactly. So instead of the LLM having to think out loud every step of the way, this coprocessor gives it a separate space to work things out.
Okay.
It's like giving the LLM a scratch pad to do rough work on.
Okay, I'm starting to get it. A separate space to think things through.
Yeah. And this coprocessor works with what's called the LLM's key value cache, which is basically its memory of everything it's already seen.
The key value cache, right, like the LLM's memory bank. Got it.
Exactly. So the coprocessor adds these things called latent embeddings to the cache.
Latent embeddings. That sounds complicated.
It sounds technical, but think of them like insightful notes or hints. They provide extra information that helps guide the LLM to better decisions.
Okay, so it's like giving the LLM extra clues.
Yeah.
To help it reason better.
Exactly, like having a super smart research assistant whispering helpful tips in your ear as you work. And this whole thing happens in three main steps. First, the LLM looks at the input, like a question or a whole story, and then it creates that key value cache, that snapshot of its understanding. But the LLM itself stays frozen during this process.
Frozen, like it's taking a break.
Kind of, more like it's a library of knowledge, ready to be accessed, but not actively changing.
Got it. So the LLM is like a library, and then
the coprocessor comes in.
Right?
It analyzes the LLM's understanding and adds those helpful notes, those latent embeddings, to the relevant parts of its memory.
I see. So the coprocessor is like the librarian who knows exactly which books to pull off the shelves.
A perfect analogy. So then in the final step, the LLM uses that enhanced cache, packed with insightful notes, to generate its output. It's had the time to think things through.
So it's had time to, deliberate, hence the title of the paper.
Exactly. Deliberation in latent space. But the question is, how does the coprocessor know what kind of notes to add?
Yeah, that's what I was wondering. It's not like someone is manually telling it what to do, right?
Exactly. And that's what makes it so cool. The coprocessor is actually trained using the LLM's own language modeling abilities. It learns to create embeddings that make the LLM better at predicting future tokens, which means
It gets better at reasoning.
you got it. And the coolest part, this whole system can be trained super efficiently using standard machine learning methods. No need for complex, resource-heavy techniques like reinforcement learning.
Wow, that's a big deal, especially with how resource-intensive AI training can be, so it's efficient and effective.
Yes. And on top of that, the coprocessor can work in the background while the LLM is busy doing other things.
Like a silent partner, so they're working in parallel.
Exactly. But does all this actually work in practice? Well, they tested it out with Gemma 2.
Gemma 2?
It's a large language model developed by Google. And guess what? They saw some impressive improvements, especially on tasks that need serious reasoning, like question answering and solving math problems.
So it's not just a theoretical concept, they've actually got the results to prove it.
And here's the kicker. The more latent embeddings they added, the better the results became. It was like giving the LLM more time to think, more time to deliberate.
That makes sense. The more information it has, the better it can reason. It's like giving someone more time to prepare for an exam. The more time they have to study, the better they'll perform.
Precisely.
Yeah.
But the researchers didn't stop there. They wanted to find the best way to configure this coprocessor.
Oh. So did they just build it from scratch? Or did they try different approaches?
Well, they tried both, actually.
Oh, really?
Yeah, so one approach was to just train the coprocessor completely from scratch, like starting with a blank slate.
Right from the ground up.
Exactly, yeah. And but then they also tried something pretty cool. They took a pre-trained model and then just fine-tuned it.
So it's like teaching someone a new song instead of teaching them how to play an instrument,
Yeah, that's a great analogy.
They already have that base.
Exactly.
Yeah.
And the surprising thing is that starting with the existing knowledge actually worked better.
Really?
Yeah, it seems like even for AI, having that good foundation can really make a difference.
It's like not what you know, but who you know. You know what I mean?
Yeah, exactly. Even in the AI world, connections matter.
That's right. And, if the coprocessor can leverage pre-existing knowledge, then it can focus more on learning the specific nuances of reasoning.
Yeah, instead of having to learn everything from scratch.
Right. Exactly.
Interesting. Okay. And they also experimented with this technique called LoRi.
Lori.
Yeah, the LoRa. And it's a way to efficiently update a model's parameters. So like giving it a targeted upgrade.
Interesting. So instead of like overhauling the entire system, you're just making targeted tweaks.
Yeah, exactly.
So using Lori, did they get even better results?
They did, yeah.
Yeah.
Not as dramatic as like fine-tuning the entire model,
Okay.
but still a significant improvement, especially if you're like working with limited computational resources.
Right. You're looking for those shortcuts.
Yeah, finding a shortcut to better reasoning.
I like it. Okay, so you mentioned earlier that the researchers, they compared their coprocessor method to some other techniques out there.
Yeah.
I'm curious to hear more about that. How does it stack up against the competition?
Yeah, so one of the methods they compared it to is called pause token.
Pause token.
Yeah, and this technique, it uses fixed embeddings. So it's kind of like giving the LLM, a generic set of notes, regardless of what the problem is.
So it's like a one-size-fits-all approach.
Yeah, and, one size fits all doesn't always work.
Right, exactly.
Their coprocessor, though, it generates context-dependent embeddings. So those insightful notes are tailored to the specific information that the LLM is processing at that time.
Okay, so it's much more specific.
Yeah, a more tailored approach.
And so how did the results compare?
Their method, it completely outperformed pause token.
Really?
Yeah, both in terms of predicting the next token and also on a challenging set of math problems that's called GSM-8K benchmark.
Okay, GSM-8K, I'll have to look that one up. But so it sounds like their method is much more effective.
Yeah, so the difference between having a general purpose map and having a GPS that gives you turn-by-turn direction.
Right, you know exactly where to go. Exactly. Okay, what about the other method that they compared to zero-shot QT?
Zero-shot QT.
Yeah.
What is that one all about?
So it stands for chain of thought prompting.
Okay.
And it basically involves telling the LLM to think step by step.
So like show your work.
Yeah, exactly.
Interesting.
So it's more about making the LLM's thought process transparent, whereas like the coprocessor approach is like more behind the scenes.
Right. Okay. I see the difference there.
And while zero-shot QT, it can be effective, it can also be pretty computationally expensive.
Because it has to generate all of those steps.
Exactly.
Whereas the coprocessor does all the work in the background.
You got it. And once again, their coprocessor method, it outperforms zero-shot QT on that same GSM-8K math problem benchmark.
Okay, so really impressive performance overall.
Yeah, and it shows how efficient this approach can be.
Right, so the coprocessor, it's doing all the heavy lifting, but it's letting the LLM shine,
Right.
look like it's this reasoning superstar.
Yeah, it's like the silent partner. Exactly, and this is all incredibly fascinating, I have to say, but, I think it's also important to kind of step back for a moment and think about the bigger picture.
Yeah.
What does this research really mean for the future of AI?
That's a great question. I think it points to a really exciting shift in how we're thinking about AI. It's not just about creating AI that can like mimic human language, but creating AI that can actually reason.
Yeah, it's like we've been so focused on teaching AI to speak, and now we're finally like, oh, wait a minute, we need to teach it how to think too.
Right. And with this coprocessor approach, we might be on the edge of unlocking like a whole new level of intelligence in LLMs.
Imagine AI systems that can actually critically analyze information, draw logical inferences and come up with creative solutions to problems.
Yeah, it's like taking those LLMs that can write you a decent blog post and turning them into collaborators who can help contribute to scientific breakthroughs or write like a captivating novel.
Or even address global challenges like climate change.
Exactly.
It's not about replacing human expertise, it's about amplifying it.
Giving us the tools to tackle challenges that, have seemed impossible.
Right, and it's an incredibly exciting prospect, but I think it's also important to acknowledge that any technology that's this powerful also comes with responsibilities.
Oh, absolutely.
We need to be mindful of the potential implications and make sure that these systems are being used for good.
It's like we're opening this door to a whole new world, and we need to proceed with both caution and a sense of wonder.
I think that's why this research is so crucial. It's not just about the technical advancements, but also about sparking these important conversations, about the future that we're creating with AI.
Yeah, finding that balance between pushing the boundaries of what's possible, but also using this technology responsibly.
And I think that responsibility doesn't just lie with the researchers who are developing these systems, but it's also on all of us, you know?
Right, it's a conversation that we need to be having together,
Absolutely. We need open and honest discussions.
involving diverse voices and perspectives.
Yes, exactly. And this research, with its focus on improving reasoning, it's a powerful step in the right direction. It's pushing us to think about what's possible
Yeah, and to consider those ethical
and
implications.
to embrace the challenges that come with, creating this future where AI plays such a major role.
It's a deep dive that's taken us beyond just the technical details and into this realm of really profound questions about, like, what does it even mean to be intelligent?
And it's definitely left me with a sense of wonder and anticipation for what the future holds.
And we are back for the final part of our deep dive into AI deliberation. This research really has me thinking about all the amazing possibilities of AI.
It is pretty incredible to think about how far we've come. It's like we've moved beyond just teaching AI to mimic us to actually teaching it to think.
Exactly. And it's this coprocessor idea. It suggests that maybe we don't need AI to be smarter than us. What if it's more about creating AI that can work with us, like augmenting our own abilities?
Giving us a cognitive upgrade, right? Think about fields like, medicine or scientific research. Imagine AI helping us analyze data and find patterns we might
Oh,
miss.
yeah, like AI helping us discover new treatments or new sources of energy.
Exactly, the possibilities are huge.
It's like we're opening up this whole new world of potential, and it all started with that question of how to make AI think better.
Right, and that's what's so fascinating about this coprocessor approach. We're essentially giving LLMs a dedicated space to think things through, to really process information.
And you said earlier, if we can do that with language, what other kinds of thinking could we help them with?
Well, think about it. How do we as humans understand complex
If
things?
we break them down into smaller pieces, right?
Exactly. We connect them to what we already know, maybe talk it through with someone. We need time to process information, make connections, and come to conclusions.
And that's what this coprocessor is doing for LLMs, but with language. So what if we could apply that same idea to other forms of reasoning?
Right. Imagine AI that could reason about spatial relationships, like an architect, or AI that could think about abstract concepts, like a philosopher.
Wow, that would be amazing. It's like unlocking whole new realms of problem solving.
Exactly. But remember, as exciting as all of this is, we need to develop and use these technologies responsibly. It's not just about the what, but also the why and the how.
Right, we need to make sure we're using AI for good and not causing any harm. It's a powerful tool that requires careful consideration.
I agree. And as we wrap up this deep dive, I want to leave our listeners with this. The future of AI is not set in stone. It's something we are all shaping with our choices and actions. So let's work together to create a future where AI empowers us and makes the world a better place.
A future full of possibility and wonder. Thanks for joining us on this incredible exploration of AI deliberation. It's been a fascinating journey.